Okay, so lesson 34 is about implicit differentiation. So far we've been doing differentiation with explicit equations that are in explicit form, meaning y is by itself, and then all the other things are x's. Not necessarily all the other things with the product rule, sometimes not, but we always had y by itself and everything else on the other side. All right, so we've been doing that. Now we're going to be doing situations where the equation is not in explicit form, it's in implicit form, which means there's stuff on both sides, all kinds of stuff. And it's just a basic process that you follow, and you just do whatever the process says to do. Okay, so here's the process. If you're going to take the derivative of a function with respect to x or y or t or whatever, okay, it's always going to tell you you're finding the derivative with respect to some letter, because this equation could have lots of different letters in it, and you have to know which letter is supposed to be, d dx, d dt, d ds, what, So when you find the derivative of the function with respect to some letter, first thing you do is you find the differential of each term on both sides of the equation. So remember, terms are separated by pluses and minuses. So you look at each term on both sides of the equation and you take the differential of each one. Okay? And then you're going to divide every term by either dx, dy, dt, or d whatever, depending on which letter you are taking the derivative of the function with respect to. All right, so like in this example right here, it's saying to find dy dx. That means you're finding the derivative with respect to x, whatever's in that denominator. So if you're doing that problem, you would divide every term by dx, because x is dx. X is the letter that you're taking the derivative with respect to. All right? And then you solve for the derivative. Okay? And it'll make sense with examples, because talking about it is not helping. Okay, so let's do that example right there. All right, so if we let xy plus 1 equal 2x minus y, and we want to find the derivative of that function dy dx, here's what we do. Step 1, we find the differential of each term. All right, so the first term here is xy. That's a product of two different functions, remember? So the differential of x is just dx. The differential of y is dy. All right, so when we find the differential of a product, remember we do first function times the differential of the second function plus the second function times the differential of the first function. All right, and then the next term we have is 1. That the differential of that is just 0. And then over here we have the first function we have, the first term we have is 2x. So the differential of that is going to be 2 dx. Remember, because the d dx, sorry, just to make sure you're not getting lost with all these letters. Remember, d dx of the function 2x, which is what we're dealing with here, is equal to 2, right? The derivative of 2x is 2, right? Multiply both sides by dx to find the differential. So the differential of the function 2x is 2 dx. So the differential of that term is 2 dx. And then the differential of y is just dy. All right, so now you've found the differential of all the terms, and now you're going to divide every term, in this case, by dx, because that's the thing that you're finding. So dividing everything by dx. dx, dx, dx. Some of these are going to cancel, like here and here. All right, So now you're going to have x dy dx plus y equals 2 minus dy dx. Now the thing you're trying to find, all right, is dy dx. So we're going to use algebra to get dy dx by itself. So we're going to put all the dy dx's on one side. So I'm going to add dy dx to both sides. So I'll have x dy dx plus dy dx. And then I'm going to move the y on the left side over to the right side. So we'll have 2 minus y. And now I'm going to factor out the dy dx. And I know that's not much room here. Dy dx times x plus 1 equals 2 minus y. And so to get dy dx by itself, divide both sides by x plus 1. So dy dx is equal to 2 minus y over x plus 1. Okay, so here's another example. We have given that y squared minus xy equals sine x, and that both x and y are functions of time. Find dy dx, dx dy, and dy dt. Okay, so first thing we're going to do is find dy dx. So, A. First thing we do every single time we do this kind of problem is we find the differential of each term. So first term is y squared. The differential of y squared, I'm not going to go through it again, we've done it before, is just 2y dy. The differential of xy, that's a product, so it's going to be first thing times differential of the second thing, plus second thing times the differential of the first thing. So minus x dy plus y dx. And then on the right side, we have sine x. Differential of sine x is cosine x dx. All right, so now we have all this stuff, and since part A, we're finding the derivative with respect to x, we're going to go through and divide everything by dx. So divide by dx, divide that whole thing by dx, and divide this by dx. So that's going to cancel. Yeah, I should have distributed that negative sign, but anyway, I'll just rewrite it. So 2y dy dx minus x dy over dx minus y dx over dx equals cosine x. All right, so the dx here also cancels. All right, so we're looking for dy dx, so now we're gonna isolate dy dx. So everything with a dy dx I'll put on the left, so 2y dy dx minus x dy dx equals y plus cosine x. And now we're going to factor out the dy dx. And then we divide both sides by 2y minus x. We're going to get that dy dx is equal to y plus cosine x over 2y minus x. So every time you do this problem, you're always going to start by finding the differentials of each term in the problem. So that step, we don't have to keep redoing that. All we have to do differently on B and C are divide by, in this case, we'll divide by dy, and in this case, we'll divide by dt. So, yeah, that's the only difference. And then we'll solve, in part B, we'll solve for dx dy, and in part C, we'll solve for dy dt. Okay, so now I'll do part B. So again, we find the differentials of all the terms in the equation. So 2y dy minus x dy plus y dx equals cosine x dx. So we found the differentials of everything. All right, now since we're trying to do this in terms of, or with respect to y, we're going to divide everything by dy. So dy, and dy. All right, these cancel, and so we end up with 2y minus, the first thing we're going to get here is x dy over dy, so the dy's will cancel in that first part, and then minus y dx dy equals cosine x dx dy. All right, now we're looking for dx dy, so we get all the dx dy's on one side. I'm going to get them all on the right side. So 2y minus x equals y dx dy plus cosine x dx dy. Now we're going to factor 2y minus x equals dx dy times y plus cosine x, and then we divide both sides by y plus cosine x, and we're done. Okay, and now we'll do part C. All right, again, same exact way we did before. 2y dy minus x dy plus y dx. Oops, I'm just going to go ahead and say minus there because I'm just going to distribute that minus sign. Minus y dx equals cosine x dx. So differentials of everything. Now, since we're looking for in terms or with respect to t, we're going to divide everything by dt. So dt, 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 dt. Okay, so we're looking for dy dt. So we're going to put all the things that have a dy dt on one side. So that would be these first two terms. So 2y dy dt minus x dy dt. Leave that on the left side and then move everything else to the right side. So y dx dt plus cosine x dx dt. All right, now I'll factor on the left side, I'll factor out the dy dt. And then I will divide both sides by 2y minus x. First, just to make it not look so messy, I'm going to go ahead and factor out the dx dt on the right side. So I'll rewrite this. dy dt over here, 2y minus x equals y plus cosine x. I'm just factoring out the dx dt. And now I'll divide both sides by 2y minus x. And that gives me my dy dt. So dy dt equals that big ugly thing there. Y plus cosine x over 2y minus x dx dt. Okay, so here's another one. We've got if x squared y minus y e to the x equals cosine x, what is dy dx? All right, so we're looking for dy dx. First thing we do, no matter what kind of thing it is we're going to take the differential of every single term here. So we have three terms. First term is x squared y. We use the product rule to find the differential. All right, remember? So it's first thing times differential of the second thing plus second thing times the differential of the first thing. So when I find the differential of this, it's going to be first thing times the differential of y, which is just dy. And then second thing, which is y, times the differential of x squared, which is just 2x dx. All right, so that was the first term. Second one, again, it's a product, so I'm going to put it in parentheses. First thing times differential of the second thing times the differential of the first thing. So first thing, y then e to the x dx is the differential of that, plus second thing, which is e to the x, times the differential of the first thing, and the differential of y is just dy, 1 dy. And then for cosine x, the differential of that is going to be negative sine x dx. All right, so we got all the differentials. Let me just go ahead and make it look a little better here. So x squared dy plus 2xy dx minus y e to the x dx minus e to the x dy equals negative sine x dx. Now we were looking to find this with respect to x, so we're going to go through and divide everything by dx. So dx, 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 dx. All right, some of those will cancel here and here and here. All right, so I've got x squared dy dx plus 2xy minus y e to the x minus e to the x dy dx equals negative sine x. And now I need to solve for dy dx. So I'm going to get all the dy dx's on one side and everything else on the other side. So x squared dy dx minus e to the x dy dx equals negative 2xy plus y e to the x minus sine x. Now I'm going to factor out the dy dx on the left. And then I'm going to divide both sides by x squared minus e to the x. And that is my answer.